First of all, this is learner book page number 15. On page number 14, we learned already how we can. Question is saying use different first terms to make sequences that all have the term to term rule add 3. Mean you have to make different sequences and the rule for each sequence should be add 3. But you have to remember one thing, each sequence should have a different first term. Okay, like there are situations given to you here, we will do them according to the situation. But what will be common in all these sequences, that to make the sequence you have to add 3. Okay, and every sequence should have a different first term. Got it? Now question is asking you, like the part A, it is asking you here, can you find a sequence for each of the following? For example, in the part A, can you make a sequence where the terms are all multiples of 3? Now, what is the meaning of the multiple of 3? Anybody knows that? What is the meaning of when I say a number is a multiple of 3? Yes, very good. Yes, what is your name? Huh? Talal. Talal, can you tell me what is the meaning of multiple of 3 when we say a number? No, you are telling me the example. I want to ask what is the meaning of multiple of 3? Yes. Uh, okay, okay. Wait. Okay. Yes, sir. Good. If we say a number is a multiple of 3, it means that number you can divide by 3, that number will be in the table of 3. Okay? That number will be in the table of the 3. Okay? For example, if I write here 10, let's say 10, is 10 a multiple of 3? Is 10 a multiple of 3? Why? Because count the table of 3. 3 ones are 3, 3 threes are 3 fours are. It means 10 is not in the table of 3, so it is not a multiple of 3. Yes? So, okay? Excuse me. Understood the meaning of multiple of 3? Okay. Now, can we make a sequence where we add 3 every time and it is a multiple of 3? All terms are multiple of 3. Yes, we can make that. So, it means you can say, yes, we can make. Give one example how you can make. For example, I can say 3, 6, 9, 12, 15, like that. So many terms you can write. Look, in this sequence now, every term we get by adding 3. Yes? Every term we got by adding 3. Yes? And every single term is a multiple of 3 also. So it means we can make a sequence. Yes? Because the question is saying, no, use pencil only. Repeatedly I'm saying please use. In your learner book. Okay? So let me increase the size slightly. Okay? So it means we can make every term in this one is a multiple of 3. Yes? Yes. And how we are getting? We are adding 3. So yes, we can make such sequence. Okay, next in number B, it is saying that where the terms are not whole numbers. Now, if we say the numbers are not whole numbers, for example, if I say these number 1 is a whole number, but if I say 1.3, 1.3, it is a decimal number, it is not a whole number. It means we have a full number and there is a part of that. Yes? Like 1.3. It is not a whole number. Yes? Also, for example, if I say 2.7, it is not a whole number. So question is saying, can we make a sequence where the terms are not whole number, but every time you add 3 and get, yes, we can do that. Give any example. Let's say I'm going to give an example 3.5. You can write any other. Instead of 3.5, let's write any other, no problem. But the number should not be whole number, mean it should be decimal number. Okay? Let's say I'm going to say
4.5.
okay, you want 4.5? Okay, say 4.5. 4.5 is a decimal number. Okay, if you will add 3 in this one, what will be the next term? It means you can say yes. Okay? What will be the next term? 7.5, yes. Because you are adding 3. Okay, what will be the next term? 10.5. Yes, you can write 2.5, any whole number, but the rule is every time you will add 3. 10.5, 10.5. Understood? Okay? So, yes, because the question is asking you, can you find a sequence? It means this type of the sequence we can make where we add 3 and the numbers are not whole number. Yes. Can you wait for some time? Let's finish then. Okay? Huh? Uh, Clear? Understood this one? Okay, then part C, where the terms are all odd. Now you know odd numbers like 1, 3, 5, 7. Those numbers which we cannot divide by 2, we call such numbers odd numbers. Okay? So can we make a sequence? Can we make a sequence where we every time add 3, but every time get odd number also?
No.
No, it is not possible.
Yes.
You know why? Think about any starting term. Hmm. No, for example, think about any starting number. 2. Or let's start with 1, no problem. Okay? If you will add 3 in this one, the next term will be 4. If you add 3 in this one, the next term will be 7. Add 3, the next term will be 10. So you can see all numbers will not be odd by adding 3, 3. Yes? We cannot make any such sequence where we add 3 every time and still all terms will be odd. Understood? Okay?
It's not at 1.1.
So we cannot make any such sequence. Now, number D, where the terms include between 100, include both 100 and 127. So yes, we can make such sequence. How? As you have to start with the 100 and every time add like 100, 103, 106, 109, okay? 112, 115, 118, 121, 124, okay? 127. So look, we added every time 3, yes? And we made the sequence where there were both 100 and 127, yes? It means we can make such sequence by adding 3 every time. Okay? Abdul makes a number sequence, okay? Abdul is a student, he is making a number sequence. And the first term of the sequence is 397. The first term of the sequence is what? 397. Now, his term to term rule is subtract 3. Mean if he has to get the next term, he will minus 3. Abdul says, if I keep subtracting 3 from 397, I will eventually reach 0. Is he correct?
No.
Why? What do you think? Why you think that? Why he is wrong? Like he started with 397 Can he reach to 0? Look, if you will subtract 3 every time, it means your jump is of 3 every time. Yes? Now, 397 you cannot divide by 3, but 0 you can divide by 3. It means if you will minus 3 every time, you are starting with a number which is not a multiple of 3. You cannot reach to a number which is a multiple of 3. Okay? 0 is a multiple of 3, but 397 is not a multiple of 3. So if you will minus 3 every time, you will not be able to reach a multiple of 3 because 0 is a multiple of every number. Remember that. Okay? Got it? So now it means you will say, if I keep subtracting 3 from 397, I will eventually reach 0. Is it correct? So say no. What is the reason? Because 397 is not a multiple of 3. And obviously, if the starting number is not a multiple of 3, you cannot reach to a multiple of 3. Yes? If you are starting with a multiple of 3, so you should must reach every time you subtract to the multiple. And 0 is a multiple of 3. 397 is not a multiple of 3. It means you cannot reach to 0. Okay? So he is wrong. Understood?